The topic for this research report is vision systems for autonomous vehicles. With numerous advancements in vision systems, robotics, and artificial intelligence, autonomous vehicles have become predominant in today's society. There are now many different types of autonomous vehicles that are used to help improve society. Some of these include automated guided vehicles, autonomous mobile robots, and unmanned aerial vehicles. To remain fully autonomous, these vehicles are equipped with advanced technologies and vision systems. These help them be spatially aware and react to their surroundings. The most commonly used systems across autonomous vehicles are radar, LiDAR, cameras, and communication devices such as radio and Wi-Fi. One of the earlier path-following systems used was magnetic strips, followed by RFID, and now fully coded software programs that allow them to plan a path on the spot. From this, it can be seen that autonomous vehicles have significantly benefited society. They have done this through reducing work required for systematic tasks, improving efficiency and consistency, and reducing risks involved. This has been mainly used for tasks such as transportation and assembly, as the vehicle vision systems can be utilized to accurately interpret the world around it, allowing for the vehicle to be independent. This allows for the vehicle to carry out tasks that would normally require significantly strenuous labor, time, and cost if completed by a human. Going into different types of autonomous vehicles, they are predominantly used in places such as factories and in the military. They can be used for multiple different tasks or jobs based on their design. However, they are usually purpose-built to be very effective at doing certain tasks. Some of these tasks include transportation, assembly, and reconnaissance, with a different type of autonomous vehicle being built for each. The types that will most likely be built are an automated guided vehicle, an autonomous mobile robot, and an unmanned aerial vehicle, respectively. Automated guided vehicles, known in short for AGVs, are used mostly for transporting parts around a facility. Specialty and newer designs can be equipped with better frames, giving higher IP ratings. These higher IP ratings allow them to transport parts outdoors without worry of being damaged from things such as dirt and water. AGVs come in multiple forms, such as unit loads, forklifts, and tuggers. The unit load AGVs are used for transporting a single product, usually on a pallet or in a bin. The forklift AGVs are autonomous forklifts used to move pallets and utilize many sensors to ensure that they do this safely. Finally, there are tuggers, also known as towers, and as their name implies, they are used to tow carts, which can be designed for various uses. For an example, the Toyota plant in Cambridge uses Mouse Tugger AGVs to move parts around their assembly line. The next type of robot would be the autonomous mobile robots. They are used in a wide variety of applications, from last mile delivery to security, as they are extremely versatile. While AGVs follow a predetermined path and are unable to navigate around any obstacles in its path, AMRs utilize maps created from its onboard sensors or preloaded building drawings to understand and navigate through its environment, without assistance by an operator. This increased functionality grants AMRs increased flexibility to navigate between locations using its own custom pathways, allowing it to easily function in a dynamic work environment. Additionally, due to the increased quality and quantity of onboard sensors, AMRs have an increased level of safety within the facility through the dynamic collision avoidance with any infrastructure, people, or products. As the AMRs do not require any physical markings to follow, they are able to be operated outside of a building or even follow an operator for increased functionality. However, AMRs are susceptible to getting lost in environments with similar looking infrastructure or without any recognizable infrastructure. This makes these robots best suited for applications in unstructured environments such as deliveries and intralogistics between a person and goods. Moving into the next, we have unmanned aerial vehicles. Unlike other types of automated vehicles, UAVs are airborne and able to fly. They are predominantly used by the military and search and rescue teams, as they are good for surveillance from the sky. They can be equipped with things such as cameras for taking photographs to special equipment for taking topology of the land. They help create maps and can be used to search for people or even detect dangers in an environment. Due to the complexities of flying, UAVs are also armed with many other technologies outside of their vision systems to work properly. However, in the end, they are simply an autonomous aerial vision system. Their main purpose in the military was to be very discreet and fly dangerous missions. This is because they can be built smaller, as there is no need to create a spot to place a human, and they can also fly into high-risk areas, as there is no risk of losing a human life. Finally, going into the last section of self-driving cars, one of the newest and most upcoming autonomous vehicles are the self-driving cars. Two of the largest companies leading this push are Tesla and Alphabet Inc., or more known as Google. The most interesting thing about these is that they will be one of the first autonomous vehicles designed to be used by the general population instead of an industry. The self-driving cars have been classified into 6 different levels. Each level represents how autonomous the vehicle is, with level 6 being fully autonomous to the point where a driver could even sleep while operating the vehicle. To create a full map around the car, it uses a combination of many systems. Some of the systems include radar, LiDAR, sonar, and cameras to collect information on surroundings, as well as GPS, odometry, and inertial measurement units to determine speed and location in the world. For operation by the general public, self-driving cars will use a general path generating system such as something commonly known like Google Maps to create a path from its start to end destination. Then, it will constantly monitor the sensors that make up its vision system to ensure it obeys traffic laws such as lights, signs, and to ensure it drives safely among cars and other pedestrians. This will ensure that there is a very low chance of an accident or an object or person being missed by the car. They can be used to hopefully reduce accidents and improve traffic conditions on the road in the future. From here, we step into the different types of technologies that are used on the vision systems for autonomous vehicles. Without the advancements of certain technologies, specifically those of vision systems, autonomous vehicles would be nowhere near as effective as they are today. From mobility and spatial technologies like radar, GPS, LiDAR, and cameras, to communication and path planning technologies such as radio, Wi-Fi, magnetic strips, and RFID, all coming together, then autonomous vehicles would not be independent. However, with the advancements in technology, autonomous vehicles are fully independent as they can be spatially aware and are able to react to changes in their environment as well as maintain their safety and efficiency. Stepping into the first technology, we will look into radar and GPS. Radar, short for radio detection and ranging, is a detection system that utilizes radio waves to detect, locate, track, and recognize objects over large distances. Radar send electromagnetic waves out as short pulses. The radar then waits as these signals can be reflected by objects in their path, partly returning back to the radar. The radar calculates the distance and size of the object based on the time required for the pulse to return and the angle received from the reflection. Radar was originally used for military purposes, used to locate ground, sea, or air targets. However, its application has now expanded into civilian fields, commonly used in applications for automobiles, ships, and aircraft to detect nearby objects in the environment. Additionally, radars can work together with one acting as an emitter and the other as a receiver. This technology can be further expanded on to create a global positioning system, more commonly known as a GPS. It is a satellite-based navigation system. This technology uses multiple satellites that all emit signals to be received by a device on the ground. The receiver then decodes each of the signals and uses the information to calculate its current location through correlating the sent and received signal time to the distance from each satellite, triangulating the device's position.
LiDAR. LiDAR stands for light detection and ranging, used for determining distances to objects. LiDAR targets an object using a pulsed laser and measures the time for the reflected light to return to the receiver. These light pulses can generate precise three-dimensional information of the physical environment around it. Common LiDAR devices utilize the GPS receiver to track the current location of the LiDAR so that the three-dimensional information can be combined to create a map of the environment. LiDAR devices are commonly used with airplanes and helicopters to create a three-dimensional LiDAR map over a large area. LiDAR uses light signals that work in the nanometer range, allowing for data of a much higher resolution than traditional radar systems to be collected. This is at a cost of covering less range when compared to radar that uses radio waves with a significantly larger wavelength, resulting in more power over larger distances. Magnetic strips and RFID. Due to the available technology, when AGVs and AMRs were first created, the autonomous vehicles had to have a track on the floor for it to follow. The guiding track was made from a magnetic tape with its south pole facing upwards. This will span the entire distance the vehicle travels. The south pole magnetic field is picked up by the track sensor on the vehicle. Its shape is a long strip. The autonomous vehicle can determine its location relative to the tape as the sensor has 3 different bits on its strip: far left, center, and far right, which will turn on or off based on the strength of the magnetic field reading at those locations. For example, if the far left position of the strip is activated, it will cause the left wheels to turn slightly faster, moving the vehicle slightly to the left. Once far enough to the left, the far left sensor will turn off. To allow the autonomous vehicles to receive commands, tags made of the same magnetic tape, but with the north side up, are placed. Based on the software programming the vehicle is operating, it will do different things based on the tag it reaches. For example, it can stop at intersections, turn, and adjust max speed. These do not interfere with the constant monitoring from the vision systems such as LiDAR, used to detect the objects and prevent collision. Since the tags themselves are not programmed and are just checkpoints, they are placed alternating left and right sides of the track tape. This allows the AGV to ensure that it does not miss a tag, as it must go left, right, etc. Since the tags are on both sides, there are two tag readers, one on each side of the track reader. RFID tags have been introduced to replace the magnetic tags, as they have been programmed to tell the autonomous vehicles what to do instead of just acting like a marker. Communication, radio/Wi-Fi. Originally, autonomous vehicles used radio signals to communicate with a central computer. This computer would help give commands to a fleet of those vehicles to ensure they are all operated more efficiently, as they are more aware of each other. Not only this, but it allowed the vehicles to use its computing power in situations that required immediate action. Even more importantly, when working side by side with people, it allowed the people to track the vehicle as well as see important update on their status. Finally, the computer could store information given by these vehicles, which could be accessed and analyzed to see issues or improvements with the systems. The advantage of this was the radio system can travel fairly far. However, the signals can be distorted based on what the facility was doing. With many new technologies now, the autonomous vehicles have been upgraded with faster communication technologies such as Wi-Fi and Bluetooth. These allow the vehicles to better connect to devices and computers, some even being able to be monitored and communicated with over a smartphone app. This allows for the vehicles to be much more versatile and adaptable in different usages. With autonomous vehicles being integrated into society and working alongside humans, there are many benefits. They allow for reduced workload, as the autonomous vehicles do not require a human to operate their tasks. The vehicles can also improve the efficiency and reliability of the tasks, as they can usually complete tasks faster and more accurately than a human, especially repetitive ones. Finally, one of the best benefits is that the vehicles can decrease injuries by improving safety. The autonomous vehicles do this by being able to operate in dangerous conditions and do repetitive tasks. With further advantages in the future, the autonomous vehicles could provide even more benefits. Reduced workload. One of the first and most noticeable benefits of the autonomous vehicles is their ability to reduce workloads, and they can accomplish this in many ways. The first is that they can either need no human operator, or that multiple can be operated by a single person. So this reduces the amount of people needed to run the facility or a task. They can also be used in conjunction with humans to reduce the amount of effort required by the person, such as lifting and transporting heavy objects. Without the vision system, these vehicles would be required to be controlled by an operator, removing these benefits. Improved efficiency and reliability. As these vehicles can function independently and follow very specific guidelines, they can ensure accuracy and consistency. The ability for autonomous vehicles to complete repetitive tasks quickly, as well as follow the exact instructions, they complete tasks promptly with high degrees of precision. As these vehicles can be purpose-built, the rigid structures allow for high efficiency and task completion. Combined, this allows for businesses to create and transport high-quality items for a reduced cost in a shorter time. On the consumer side, this can result in reduced wait times and lower price points. It can also allow for more work to be done with less manpower if the number of workers is low. C. Decreasing injuries. These vehicles can consistently monitor the surrounding environments using vision systems, resulting in increased levels of safety. Coupled with following the best safety practices, these vehicles are better equipped to perform the job as safely as possible. They also have the ability to work in environments considered dangerous to humans due to tight spaces, heat, noise, and more. Completely removing the people having to go in these places completely removes the risk of injury. Also, they can be used for carrying out strenuous tasks that can lead to injury, such as heavy lifting and reaching high areas. Finally, the autonomous vehicles can be used for repetitive tasks. Repetitive tasks can cause long-term injury to muscles and cause things such as arthritis and muscle strains in people. Therefore, having these tasks done by the vehicles will help prevent that. The conclusion. There have been many advancements in vision systems, robotics, and artificial intelligence to equip autonomous vehicles with the capabilities to be spatially aware, react to their surroundings, and remain fully autonomous. Autonomous vehicles are designed to use a wide variety of systems such as radar, GPS, LiDAR, magnetic strips, and Wi-Fi to design an integrated system to build autonomous vehicles for any tasks. There are many types of these vehicles used in today's society, such as automated guided vehicles used mostly for transporting parts around a facility, autonomous mobile robots for last mile delivery, and unmanned aerial vehicles to be used by the military for search and rescue applications. From this, it can be seen that autonomous vehicles have significantly benefited society. They're able to reduce work required for systematic tasks, which improves efficiency, consistency, and minimizes risk involved. This allows for vehicles to carry out tasks that would normally require significant, strenuous labor, time, and cost if completed by a human. Our references are below. Thank you for listening.